Okay, so it says a water tank has the shape of an inverted circular cone with base radius 2 meters and height of 4 meters. If water is being pumped into the tank at a rate of 2 meters cubed per minute, find the rate of which the water level is rising when the water is 3 meters deep. Okay, so it's an inverted circular cone, so we know to draw this shape, and it's inverted. Okay, so it says the base radius is 2 meters, so that means that the base radius right here is 2 meters and has a height of 4 meters. So the height would be 4 meters. And it says the water is being pumped into the tank at a rate of this one. So if it is being pumped into, that means it's taking up space. So that would be volume. Oops. Put it here so it doesn't. So V equals volume, and we're given a rate of change, so derivative of volume in respect to time is 2 meters cubed per minute. Okay, and then it says find the rate at which the water level is rising when the water is 3 meters deep. So it tells you the height, or how deep it is, because we know, yeah. Okay, so h is height, and they're giving us h equals 3 meters. So it says we're finding a rate at which the water level is rising. So we're not asking how much it's like taking up, but we're just asking how much it's like going up by, which is the height. So we have to find the height in respect to time. Okay, now we're given our equation already which one to use, but we already know what to use because it's a cone. So it is v equals 1 over 3 pi r squared h. And then if we take the derivative from the other worksheet, or you can do it yourself, it would look something like this. Okay, so it would look like this, and we want to start plugging in. We already have this one, so that's 2 equals pi over 3 2. No, we want to find the radius, and even though it was given to us right here, this is not the radius for here. And we know that because Ms. Hernandez was telling us, like, oh, it's going to change as you go up, because, you know, it's cone, it's getting wider. So to find the radius, we note here that the radius is half of the height. So the radius, because it's 2 over 4, it would be half of the height. And then another way to write this is just h over 2. So now we have our r. It's h over 2, and we have h, which is 3 over 2. And then we have our height. Our height is 3. And now what is our rate of change of the radius? So we have this as a function. So all we have to do is just find the derivative of that. And that's 1/2 if you use the chain rule or the product rule. Either or. That would be dh over dt. So this one turns into this. Because, yeah. This would be these two, if that makes sense. And then plus, I'm just writing it on the bottom because I'm running out of space. R, which we've established, is our h over 2, and h is 3. So 3 over 2 squared, and then dh over dt. And now we just plug it into the calculator. So you could take this time to do it yourself. 2 equals pi over 3. We have all these that we're multiplying. I'm going to multiply the numerators first, just because that makes it easy on me. 2 times 3 times 3 equals 18. Over, and then the denominators, 2 times 3 equals 4. dh over dt plus, this is 3 squared, which is 9. 2 squared, which is 4. dh over dt. And now we see that these are like terms, so we can just add them up. 18 plus 9, they already have the same denominator, so this is going to be 27. 27 over 4, and then you bring down your dh dt. So we rewrite it again. 2 equals pi over 3, times 27 over 4, times dh over dt. And now right here we can do a little canceling out. This one would be, what is it? Is it 3? I mean 9? Yes. This one would be 9, so it's 9 pi over 4 times dh over dt equals 2. So now we just cancel it out by division, so 2 divided by 9 pi over 4. dh over dt would give you approximately, so you do your 9 pi divided by 4, and then you do 2 divided by what you got. It would give you roughly 0.2829. Oh, she doesn't do that. So, yeah, you can either do that, or if you have a calculator, if you don't have a calculator, is just keep change, flip 9 pi equals multiply across for 8 over 9 pi. And then you have your units, which is, this is a rate, so minutes, sorry, meters per minute. And that is what she gets here. Yay.